Right. In these next few slides, we'll discuss the Fourier analysis using an intuitive problem we want to solve. And the problem is, given an unknown drink, find the composition of various types of drinks inside this unknown drink. For example, if this drink is a cocktail and it was created by some alcoholic beverages, we want to find what are the different content of the alcoholic beverage. For example, in this example, this is an unknown drink containing vodka, gin, and lime. And we want to find out how much of vodka, gin, and lime there are. But of course, we did not know it was vodka, gin, and lime. It could be vodka, gin, with whiskey, with rum, and so on. So how do we proceed to find the unknown drink is the problem that we have. And if we understand this problem, we can then relate to the problem of Fourier analysis. In Fourier analysis, the problem is to find what is the composition of the unknown cosine wave in this signal. Corollary, this is the problem of finding the unknown drink composition. How do we proceed? And here is the unknown drink, and all we know is that maybe it has a 1 liter content. And we know nothing else. And we was told to us that it is some alcoholic beverages plus some fruit juice. To analyze this unknown drink, what we can then do is to combine it with some known drinks. And for example, we suspected that it was vodka. And basically, we pour the vodka and our unknown drinks together into a funnel, and then out comes a value C vodka. And what this funnel does, it measures the content of the unknown drink, how much of ml, milliliter, as well as, for example, maybe the percentage of alcohol. And of course, this funnel is some magic funnel we now provide you, and we say that it can do that. And in the world of Fourier analysis, it's the same. The coefficients measures how much of the signal is in the unknown signal. Right, but to fully be able to decompose my unknown signal, we must not only measure it against the vodka, we must measure it against another drink. And for example, if we measure it against a drink like whiskey, and if whiskey is not present in the drink, then what we get is the content C whiskey would be 0 because there is no whiskey in the unknown drink. And we have to keep on doing this for all drinks that we suspect this is in the unknown drink. And when we have finished analyzing, and this whole process is called analysis, we can then figure out all the composition. And with the composition, we have the recipe to make our unknown drink. And this process is the analysis process. And given the recipe, we want to make the unknown drink. For example, now we know that it is vodka plus lime plus gin. And not only we need to know which is the type of alcoholic beverages it is, we need to know how much percent of alcohol is the vodka, as well as the mini, how much content. Maybe we want to make 1 liter of this alcoholic drink, and we have 100, maybe 30 milliliter, and we have maybe using a 45% alcohol kind of thing, and we have a lime, maybe we have a 20 ml, and then of course there is no alcohol, and then we have a gin, and then this gin is a 50 ml, and then this gin has 25% alcohol. When we add up this, we have the original drink with whatever percentage alcohol that we have also found in this analysis. So this is one way to explain what is analysis. In other words, analysis is a process to break our unknown into known composition, finding out the values of interest. And in the drink world, we're interested in the amount, as in milliliter, as well as the alcoholic content. 2 parameters through this magic funnel. Given the recipe, of course, we can then reconstruct. How is this related to our Fourier series analysis equation? In the Fourier series equation, we have given you this equation. Ck is given, the analysis equation Ck is equal to 1 over T0, the period, integrate over 1 over T0, the 1 period, x of t, the signal of interest, E minus jk omega naught t. Now let us relate this equation to our measuring of alcoholic content. X of t is the unknown drink. E minus jk omega naught t is the known drink, be it the vodka, the whiskey, the gin. And by multiplying together, we are actually mixing it together, each drop at one time. The function of one value is multiplied with the function of the other value. The integral is the sum that comes out of it over one period, pouring equal amount. In this example, is 100 ml of left, the unknown drink, 100 ml of the known drink. So we are integrating over one period, means we are measuring across the equal amount of 100 ml each, divided by T0, means that we normalize it. That means we are not interested in its value over 100 ml, we're only interested in its normalized version of 1 ml. Out comes 2 values in our case, Ck. Ck, when doing this, because E minus jk omega naught t will return a complex number, it will tell us 2 information. It will tell us the magnitude and the phase of E minus jk omega naught t that is contained within xt. In the drink world, this magic funnel told us 2 information. The ml, how much of this 100 ml is there vodka, and the percentage of alcohol of vodka that was used to make this drink. So that is the idea. Of course, the theory of this integral generating a measure is not of our interest. It is the application of measure theory of the function x of t, and it is beyond the scope of this course. Nevertheless, with this understanding, I hope that you will now have a deeper understanding of how the analysis equation work. In this subpart, it is the continuous time Fourier transform equation of the analysis equation. Here, because we do not have one period anymore, the integral is over minus infinity to infinity of the unknown signal of interest multiplied by the signal of interest that we are interested in this case is E minus j omega t. What we are multiplying is a complex exponential with amplitude 1 rotating at omega frequency. By multiplying this over all time and integrating, we find the composition of this signal in this unknown signal, x of t, and then we save it in xj omega, and we do this for all omega, and therefore now we can see the frequency domain representation again. So with that, once we have the analysis equation decomposing the signal into complex exponential with k omega naught frequency, we can synthesize it using this equation, and that again show us clearly what we mean by analysis and synthesis.